So with that, welcome to what is now the 35th seminar for 2021 in the Society for Conservation Biology's Emerging Issues in Conservation seminar series. In the series, we feature articles selected by the editors that have recently been published or recently accepted or in early view in the 3 SEB journals, those being Conservation Biology, Conservation Letters, and of course, Conservation Science and Practice. So my name is Martin Strauss, and I'm hosting today's seminar. I'm a senior lecturer in the Department of Environmental Science at the University of South Africa, and I'm also an associate editor at Conservation Science and Practice. And it's in that capacity that I've been organizing the 2021 seminar series. And so it's my great pleasure to introduce you today to our speaker, Courtney Melton. Now, Courtney is a PhD candidate working with the Centre for Biodiversity and Conservation Science at the University of Queensland. The research focuses on recovery options for the declining woodland bird community of Eastern Australia through improved understanding of the relationship between habitat complexity and community composition. Specifically, Courtney seeks to identify how managing sub-canopy vegetation may serve as both a resource provision for small birds of conservation concern and as a potential deterrent of one of the key threatening processes, that being aggressive exclusion by overabundant native noisy miners. So today, Courtney will tell us more about her recent paper, early online, available in Conservation Letters, entitled Evaluating the Evidence of Culling a Native Species for Conservation Benefits. And with that, Courtney, over to you.
Thanks very much, Martin. Hi, everyone. I'll just share my screen to get going. Hopefully you can all see that there.
Yes.
So thanks very much for that introduction. That's fantastic. I'm working in the School of Earth and Environmental Sciences based at the University of Queensland, just like Martin said. And just before I start the presentation today, I'd like to acknowledge that the traditional owners of the land on which I do live and work are the Turrbal and Yagara people. And I'd like to pay my respects to their elders, past, present, and emerging, as well as promote the ongoing custodianship and conservation by Aboriginal and Torres Strait Islander peoples across all the land that I've had the immense privilege to conduct ecological research. And like Martin introduced already, my broad PhD project has involved fieldwork across many Indigenous lands as I research woodland bird decline across southeastern Australia, seeking recovery options and improved management actions to respond to some of their key threatening processes. Today, I'll be talking on behalf of a wonderful group of co-authors about our recent publication with Conservation Science and Practice, evaluating the evidence of culling for conservation. And I hope to provide some context for the current status of the woodland bird community in this part of the world, and provide some context for why conservation scientists and land managers are now faced with decisions surrounding culling native species in attempts to preserve critically endangered species and retain high quality habitat for a suite of vulnerable birds. And then I'll summarize some of the findings from this analysis of a new but quite messy and valuable collective data set. So as you would have seen from that very long author note on the title slide, this is a big collaborative piece, and I've had the opportunity to work with such an inspiring group of co-authors in putting this all together. So I just wanted to say a big thanks to them and our other data contributors as well, whether that be data collected under scientific permit or those recounted by a wonderful group of landholders that did a series of interviews with me anonymously. I'd also like to thank our funders as well that helped get us all together in the same room to make something like this happen. So that's the Australian Government National Environmental Science Program Threatened Species Recovery Hub, as well as the New South Wales Government Saving Our Species Program. So when I talk about the southeast side of Australia, what I'm talking about here is this area that's marked in grey slashes, the temperate and subtropical woodland zone. And this area contains habitat consisting primarily of dry open eucalyptus dominated vegetation, but also woodland dominated by Alocasuarina acacia and Calliotra species. And this woodland zone supports a diverse community of woodland birds with over 200 different species of insectivores, granivores, nectivores, and it also includes migratory and rare species as well. So many of the species in this community play important roles in generating ecosystem services, particularly for pollination and pest control, as well as the maintenance of woodland health and generation. And some of the species that are found within this woodland zone, they're not found in any other areas and are highly specialized for these habitat conditions. As such, though, they're also critically sensitive to landscape compositional change. And this woodland bird community has suffered severe decline, with over 40 birds now listed as threatened. And this community itself has also been nominated as a threatened ecological community to our national government. And this decline is a consequence of the direct and indirect impacts of habitat loss following vegetation clearing, its fragmentation, its continued degradation under various land use pressures such as grazing and inappropriate fire regimes. And it's the loss of structural complexity in particular, both within highly modified environments as well as within areas that are relatively isolated from intense human pressures, that's facilitated a phenomenon where we have an environment that no longer has the diversity in structure and composition to support a lot of our smaller birds and specialist species, but that also more readily accommodates generalist species, some of which become a huge threat themselves. And the overabundance of native noisy miners is an excellent example of this phenomenon. They've been listed as a key threatening process in woodland bird decline nationally and in the states of New South Wales and Victoria due to their highly effective aggressive exclusion of almost all birds, but particularly the smaller birds, from the habitat that they occupy. And for anyone who isn't too familiar with noisy miners, they're native Manarina honeyeaters, which naturally occur in dry sclerophyll woodlands spanning coastal lowland areas out to the Great Dividing Range. They thrive in more open areas and are highly socially sophisticated communal breeders, which work together in these really dynamic ways to very effectively exclude almost any other perceived competitor through their group aggression. And there's considerable evidence to show that when noisy miners are present, the richness and abundance of other birds reduces drastically, with birds smaller than them, so anything less than about 60 grams, they're the most severely impacted, as you can imagine. So in the late 90s, Clark and Shedman led an experiment testing a translocation approach to managing noisy miners, attempting to mitigate the threat they pose to vulnerable woodland birds. And this translocation attempt, it was not successful because the noisy miners that were translocated, they weren't accepted into the resident colonies they were released into, and also behaved in ways that were not common of the species, traveling much further than their traditional home range, and some making it back to the area they were taken from, which was specifically designed to be beyond their reach. So translocation was deemed unsuitable for management of noisy miners. And following on from this, managers began testing lethal control of noisy miners in areas of valuable woodland habitat and to relieve pressure to critically endangered species. Now, this action is controversial due to the ethical contention that obviously surrounds the idea of harming any species, but particularly a native species in the name of conservation. And to complicate things further, the results from these studies have been really mixed. Some appear to be super successful, others have been these large failures, and some can't seem to tick either box here. But let me describe in a little bit more detail for context. So for our scientific studies, removals have been undertaken for different conservation goals, and as such, they've had reported success and failure that's been pretty mixed across. So early work by Gray and colleagues found small-scale removals over a few hectares successfully suppressed noisy miners long-term and resulted in small birds coming back to the treatment site. And then Jeeves described how an unofficial removal conducted by a landholder successfully kept noisy miner density low, with some small-scale seasonal removals conducted through the years to keep it that way. And the small birds were benefiting here, and it was deemed successful. However, later on, DeWitt and colleagues, they led a really high-intensity removal. They removed over 3,000 birds from the treatment sites, and yet this high effort failed to successfully reduce the density of noisy miners at the site post-removal due to rapid recolonization. So surprisingly, with that in mind, the small birds also appeared to have a small but significant increase in numbers at those sites. So the overall consensus for this study was that it was failing to remove noisy miners, but something unusual was going on with the small birds that warranted further investigation. Now, Ross Crates and colleagues were conducting targeted noisy miner removals at about the same time to reduce pressure that they posed specifically to those threatened regent honeyeaters. And the idea here was to clear an area of noisy miners to allow regent honeyeater breeding pairs to come in, utilize the patch of really valuable habitat. And this intervention was deemed successful because they had success with their regent honeyeaters, and they also noticed an increase in the occurrence of small birds at that removal. A few years later, Crates and colleagues did another removal. They expanded their treatment site and again observed the success in both the response of the regent honeyeaters as well as the response of small birds at that site, increasing in a small capacity. But again, around the same time, Richard Beggs and colleagues were conducting removals within an agricultural landscape, and they found that noisy miners did not reduce in density significantly and therefore did not have the significant conservation outcome that they were hoping for. So while they did note in this study that there was an increase in the small birds at the site, they went on to say that it was those small birds in particular that were quite common and potentially already able to tolerate some of the noisy miner aggression. So we've got a lot of variety here. But if we're going to continue using lethal control for woodland bird conservation, we need to better understand when and where this intervention works. So myself and this wonderful group of colleagues, we created a database of all known noisy miner removal events, organising data sharing agreements with authors of published and unpublished noisy miner removals, and invited individuals who'd undertaken permit-based or unofficial removals to participate in a phone survey that would document their observations. So in total, we collected data describing 45 different noisy miner removal events across Southeast Australia. We collected data describing ecological and methodological context. So we wanted to know what the habitat looked like around the treatment site by estimating the percentage cover of woody vegetation within 1 kilometre. We wanted to know whether there were shrubs present or absent at the treatment site because some previous studies have found that there's a negative association between noisy miner density and the presence of shrubs. The area over which the noisy miner removal was conducted gave us an opportunity to think about whether there was a specific component of the noisy miner colony that was being removed. We identified how many separate culls had been conducted and over what period of times those culls were conducted over. So, for example, was it this one-off cull or was it something that was done seasonally in the spring months, for example? We also wanted to look into the removal effort by noting the density of noisy miners removed from each cull, and we looked at the level of occupancy that the noisy miners were maintaining at the site prior to the cull by looking at their density before any of this removal was initiated. We also looked into the location and made sure to include that in our models to account for spatial autocorrelation. We used the data for these predictive variables to model 3 different types of success: the successful reduction of noisy miner density by half or more, or the increase in one of small bird abundance or small bird species richness. Now, the reason we modeled these 3 different response types was because reducing noisy miner density was not necessarily the goal here. The focus for us was whether there was a benefit to small birds of conservation concern. So we used generalized linear models to reveal which predictors influence the likelihood of success in these 3 response types. We also then undertook model averaging to produce model average coefficient estimates to see whether any one predictive variable describing ecological or methodological context was significantly correlated with success in any of these response types. So when we looked at the response variable describing a successful reduction in noisy miner density at the site by 50% or more, we found that there were no clear and obvious predictors associated with this reduction. There was a small association, you can see here this very tiny effect, suggesting that suppressed effort over time was important, but otherwise there didn't appear to be certain characteristics of the environment or the removal method that increased the likelihood that this cull would result in a reduction of noisy miner density by 50% or more. And when we looked at small bird abundance and richness following the removal, we again found that there was no clear ecological or methodological predictors of an increase of small bird abundance or richness at the site. So these results were perplexing. We had information describing all known noisy miner interventions. We knew some had been reported as successful, others recorded as failures, yet there was no clear story emerging here. And the lack of clarity and predictors of success could in part be explained by the sheer variety of removals conducted to date, which were done under a variety of ecological and methodological conditions, and were done for a variety of conservation goals too. So notably, the removal approach and treatment area and the number of removal events that were conducted at each site made it quite difficult to then distinguish the effect that these variables were having on the different measures of success. What we could distinguish, however, was that we were seeing collectively this recolonization of noisy miners happening at varying degrees across the 45 removal events. Yet despite the significant recolonization at almost all of the sites, we saw a noticeable increase in small bird species richness and abundance at most of the sites following removal, so irrespective of this recolonization density. And so when we looked into this relationship between successfully reducing the density of noisy miners by 50% or more and an observable increase in small bird occurrence in more detail by performing a chi-square test, we found that the increased species richness of small birds was significantly correlated with successfully reducing noisy miner density by 50% or more. So again, not a real clear story emerging here. So why, if all this effort is going into removing noisy miners from the site, are we seeing noisy miners at the site post-removal and in substantial density? Well, one of the main theories discussed in our big and expert author group was that these removals were essentially opening up often productive habitat to neighbouring noisy miner colonies that are even competing with each other for space. So when those colony boundaries are no longer being defended in that intraspecific aggression we see in this species, we have scouting miners potentially taking advantage of the newly occupied expanse of resources. So the recolonization is substantial and rapid. When we think about the individuals of a colony, we know that the females are the dispersing sex, and we know based on previous research into noisy miner behaviour that many of the young female noisy miners don't expend their efforts on the provision of existing nests, but instead spend most of their time scouting areas to establish their own nests. And this research was conducted by Douglas Dow. So it could be that post-removal, there's a new opportunity for females to establish their own nest. And so the females and helper males that might not have the primary roles attending to current nests in the colony that already exists pioneer this newly available habitat. Work by Jacob Vickers and his colleagues identified some of the sex of culled noisy miners that were culled during multiple cull events, and they found that there was a disproportionately young female and male group recolonizing the treatment areas. So we do have some evidence there supporting that there might be more to learn about our recolonizers. And something that we didn't really spend a lot of time evaluating in our recent paper, because that wasn't quite the objective, but that I think is really important thing to notice here, is that we could be seeing some parallels to what is commonly acknowledged in invasive species management, whereby a removal intervention leads to a higher density of the target species at the site due to this increased survivorship of immature individuals at the site that we've removed those mature individuals from. So this removal of competition. And I'm not sure we yet know enough about the noisy miner recolonizers and their behaviour to make those inferences with any certainty, but I think there's definitely a lot to learn by drawing insights from invasive species managers and attempting to apply some of those theories to noisy miner control. So why, if noisy miner density is remaining high at the site after removal initiatives, were we seeing a benefit to small birds? Well, we think it's most plausibly explained by ideas that have already been touched on by McNally and colleagues and DeWitt and colleagues in their papers about this redistribution of colony effort. So instead of directing colony effort, that's our recolonizers I'm talking about here, on driving out potential competitors and threats to resource acquisition by non-colony members, the recolonizers could instead be working to establish the new site. Or it could be, like we were talking about before, that this site is being recolonized by immature females and temporary helper males, and this recolonizing group might lack the social bonds that are critical for the colony to effectively exclude those perceived threats. There's currently more work underway by Paul MacDonald, one of the co-authors here, and his colleagues into the behavioural questions by further examination of individuals from these multiple cull events to learn more about the recolonizers. And I think that this research will really feed into this space and help answer some of those questions too. So irrespective of the recolonizers, however, the results of our study did suggest that removal interventions could remove some of the pressure to local woodland birds, at least for the short term. So what does this mean, and what do we do with these complicated messages? Well, when you look at these removals from purely a threatened species management perspective, it does look like conducting removals can relieve pressure short-term under critical circumstances. And in those really critical situations, this could be considered an appropriate management strategy. But then when we're looking at the broader situation of managing the decline of this whole community of woodland birds, we really need more data collected in a standardized way to unravel the conditions under which this management action is likely to be effective. Because culling any species, particularly a native species, needs to be well justified. And furthermore, we want to be confident that the allocation of our limited environmental resources has a high chance of success. And if data become available, maybe following on from these removals that are already approved for future events, it'd be really beneficial to understand how those combined efforts of active revegetation and noisy miner removal benefit woodland birds through time, because we were seeing a few control actions, particularly by our landholders, that were undertaken when revegetation activity was already occurring. And we know that revegetation and the rehabilitation of degraded sites is imperative to conservation of pretty much any species here. So obviously that will work. There are just situations where we don't have the time to wait for vegetation to regenerate in a way that's going to be deterring noisy miners, like with the Regent Honeyeater example. So in addition to reaffirming just how big the noisy miner problem is by, some situations we're only disrupting the social structure alone and small birds benefiting, one of the big takeaways from our work is that it's really important to monitor not only the species we're targeting in our physical management, but also the species that we're wanting to respond and ultimately benefit from this management. So continued monitoring and standardized data collection is important and can really contribute to increasing the statistical power of the analysis like we did here. And finally, and this is something that doesn't have the emphasis it deserves in our paper, is that we learn so much from our landholders if we give them a safe and inviting opportunity to do so. They have a wealth of on-ground knowledge and experience to share that can really aid in our understanding and continued research into complex problems. So I really think as conservation scientists, we should be engaging more with our landholders, especially in Australia, where so much land is tenured by private landholders as well. But that's all I have for today. I hope I didn't ramble on too much. I know some of those slides are getting a little bit bland towards the end. There's only so many times you can put a noisy miner picture in there before it starts getting a little uncomfortable. But thank you so much for sticking with me, and I'm here for any questions if you're interested. And I think there's a couple of co-authors as well on the line that might be able to help there.
Thank you very much, Courtney, for a really interesting presentation. So I'll open it up for questions. I've got a couple for you, but maybe let's first see what comes in off the floor. Maybe while people organize their thoughts. Culling is a hugely controversial topic, certainly in this part of the world, in South Africa. And I think in your part as well. I mean, there's been a whole issue about the feral horses and all of that. And how's this kind of thing perceived with birds? Is it as controversial? Are people more acceptable of it? What's the general feeling?
I think the general feeling with feedback that we've at least got from the conversation article is that people do find it quite uncomfortable, especially when we have invasive birds here as well. So a lot of the feedback that we got was like, well, why aren't you culling the common miners, so the Indian miners that we have here? And it turns out that they're not having this detrimental effect that we're seeing like with the noisy miners. So it's not a huge priority for this particular area of the world. But yeah, I think it's exceedingly uncomfortable, and I think that people that are really engaged with woodland birds will have noticed that the noisy miners are driving out a lot from their properties. So it's people that want to draw in a lot of the woodland birds into their properties that are quite supportive of the idea. But of course, yeah, it needs a lot of context and explaining why people are considering this and what the directives are for people trying to conserve these critically endangered species like the Regent Honeyeater, where they really have such small numbers, they losing their song, they can't find mates, those kind of things. So those critical circumstances people seem to be a little bit more open to, but when you're trying to conserve this whole suite of declining birds, yeah, it's quite an interesting discussion to have. And I can definitely empathize with the idea of not necessarily being supportive of culling native species. when we do need to do so much on ground with revegetation work as well.
Cool, thank you. Jeremy, you got your hand up?
Yeah, good morning or good evening, I suppose, in South Africa. Thanks, Courtney.
It's now morning too.
Yeah, I was wondering. Well, thank you so much for staying up so late. I just was going to say thanks, Courtney. That was a really great presentation. My question's actually for our South African friends on the line, though, about, I guess it's a follow-up to the first question there about this idea of culling or managing native species. From the South African experience, how are there any kind of lessons that have been learned from communicating that and explaining the rationale for managing native species for the benefit of I guess ecosystems or other species?
I'm going to dodge that one and say, Anne, would you like to answer?
Thanks, Martin. Well, I think, you know, in South Africa, we have the elephant, and being such an emotive and intelligent animal complicates the cull even more, because it adds a whole level of complexity to you are now culling this very intelligent being. And I suppose, so what we have is we have like Addo Elephant Park, where we've actually then dedicated a park for them to kind of take charge and take ownership, and they're given a space to breed and to populate, even if it is at the detriment of some other species. And I think science is learning a lot from what will go down at Addo when a popular species is allowed to breed that much. And I guess then we'll also find out in Kruger what will happen with, you see, because, well, like with the elephant, they were actually disturbing the habitat and thereby changing the habitats and getting rid of the other species. So there was always a reason to cull them, but I guess, well, there was a big outcry, and I guess we'll have to see, you know, the breeding rate did decrease when culling stopped. So exactly like all others. But yes, I mean, you guys also have those big kangaroos, and I think of a lovely paper that came out. I don't know who the author, I've forgotten who the authors were, but there's a paper that came out in Animals called The Perils of Being Populous, with the big kangaroos that you guys have there. So yes, this is I suppose a common problem. But I just wanted to say, Courtney, it was a lovely speech, because I had my questions, but then you answered them at the end. so yeah, it's nice to have that, because my question was, it's almost like a band-aid. You want to address the cause, not the symptoms. So if the habitat is changing, shouldn't we be looking at rehabilitating and revegetating, as opposed to just, because taking away the noisy miners is just it's a symptom of a sick habitat, and it's going to come back like yeah. So, but anyway, I really enjoyed your talk, so thank you. Sorry, it is after it is almost 1 in the morning. So if I'm thank you.
Thank you so much, Anne, and thank you for tuning in at such a horrendous time at your side of the world. I think your question was so well said. It's definitely reactive management, and something that needs to be paired with other interventions for sure. I do see a place for it, I guess, when we're really worried about critically endangered species, but yeah, it's not going to fix all our problems, that's for sure.
So, Courtney, in the paper you spoke about overcompensation when animals are removed and sort of new individuals move in. Do you know, or do you have any insights into the effects of overcompensation on these woodland birds where noisy miners are concerned? Is it a kind of straight relationship of more miners, bigger effect, or how does it work?
Yeah, there have been a few papers that have come out looking at like the density threshold of when noisy miners start becoming a really big problem, but it's incredibly small. So I think work by Thompson and colleagues came up with an estimate of you need about 2 miners per hectare for them to be having a really noticeable impact on the woodland bird community, which is just tiny. Yeah, so I know that we haven't spent a lot of time looking at who those recolonizers were to see like where they're coming from as well. That's why we tried to incorporate some elements of the existing habitat around the study site. You know, were we expecting noisy miners to already be inhabiting that area? That hopefully the work by one of our lovely co-authors, Paul McDonald here, I know he's got a few students that are looking into measuring where the recolonizers have come from and conducting like those future already approved culls with that in mind in their study design. So I really hope we learn more about this overcompensation problem, because I can imagine just from the little bits that I've read about the invasive species management and overcompensation in other places, that it could have quite close parallels to what we're seeing here as well. You don't need a lot of noisy miners to have a really big impact, it seems, which is quite unfortunate.
Yeah, that's quite interesting. You mentioned the public response of, you know, there are things like the Indian miner that are having an effect. And I think just in this week, I saw a reference to a new paper of the effect that removal of Indian miners in parts of Mauritius, I think, how that resulted in a 90% increase in nestling survival. If you control the Indian miner. So maybe it's a developing problem, maybe still for Australia.
Yeah.
Indian miners. But I also wanted to ask you, because you end with the management implications in the paper and also in the presentation, and you had this great almost a wish list of this is what we need to kind of fine tune as we go forward. And in my experience, kind of land managers are not necessarily particularly great at collecting data in any kind of systematic way. Is there a way that this is feasible, that you think people will buy into this and kind of work together to kind of collate that kind of data? Can it become part of the permitting kind of thing of, you know, okay, you can get a permit for the coal, but then you have to follow these approaches? What's your feeling of that?
Yeah, I definitely think there's potential for it. I can definitely understand what you mean about, you know, prioritizing tasks there and limited resources, budget, that kind of thing. We don't have a lot of time to go about sites, of course. But yeah, with that permit system, I definitely think that uptake would be something that people would consider if they were applying for permits themselves. You know, having spoken to landholders that had conducted this activity, the reasons behind it, and it wasn't something that we really focused on in our paper. The paper's long enough as it is, but one of the reasons that the landholders were doing this was because they really wanted to increase and protect the other woodland birds on their properties. So they were already interested in the woodland birds that were there, and I think asking them to have a bird list or to do a bit of monitoring before and after they did a cull, something like that, I think that would be taken up quite readily by those people applying for independent permits themselves. In terms of the permit process, I know that there's only a few states that you can get those permits from, and I definitely like to have discussions with those issuers to see if that's something we can get there. Even just getting data from those agencies was quite complicated in this paper. So we sort of reached out to the government officials, we reached out to the people that were issuing the permits, and then, you know, obviously your human ethics side of things, everything has to be anonymized. So there were invitations sent out to people that had to then get in touch with us. So it was quite a long rigmarole of trying to get to the people that had the information that we were interested in. So if there was a way that they could add to a database or something like that, that'd be amazing. In terms of our ones that are done under scientific permit, I think there's capacity to increase that. You know, I think they're already doing a really good job. Some of these things are done under government incentive as well. So we have really skilled people out in the field doing this. And if we had a plan for how that data could be aligned to best analyze it, I think giving that information to people could really help improve it. So I definitely think there's capacity, but understand that it's really challenging. We don't get much funding here and people are extremely like thinly stretched across the work they have to do. But I think it would make a huge difference if they could collect this information at the same time in a way that we can keep building this data set and keep understanding what's going on with these species.
Good, thank you. Yes, Marilyn.
Is it okay if I say something, Marilyn Gray?
Absolutely.
Yeah, I think in Victoria, the state I'm from, for a landholder to get a culling permit for noisy miners, they need to do some rehabilitation of land and perhaps fencing of remnants. And this has been for quite a few years now. And once one landholder does this, the neighbours become interested because they see the benefits of what's happening. So now there's quite a few areas where I used to go when I did my noisy miner work, where the remnants I studied in are all fenced and being rehabilitated. So there's great scope, I think, for getting the landholders on board. And I never had a problem with any of them, and that was about 30 years ago. They were all vitally interested in what I was doing and offering to help. So I don't think it'd be very difficult to get most of the landholders cooperating.
Okay, that's very good. Anne, I see you've got a question. Do you want to unmute and just ask it? Or should I read the chat?
Okay, no, it's fine then. I just wanted to know what are the different ways that these noisy miners are culled? Is there an ideal protocol or from a welfare perspective? So I'm not familiar with, I mean, I know how our quelea species are culled, but I don't know how you guys do the noisy miners, if you might share that with us.
Of course, yeah. So there was a little bit of variety, but for the most part, that these noisy miners were removed by a targeted shooting by a trained shooter. So they were shot with a shotgun. And so there were protocols that you can find in the different studies that it's outlined in, which describe like you need a person that's trained and you need like someone there to go and find the birds that have been shot, making sure that they've completely died, or they have certain practices there to end life very, very quickly. So I think that was the idea there, to try and make it as ethical as possible if you're considering something ethical when you're culling something. And a few other studies that I don't think, if I'm recalling the database correctly, I'm not sure these are the published ones just yet. They're working on that study at the moment, but there was misnetting involved in euthanasia of the birds. So we didn't really have much information about that yet because it hasn't been released in any obvious capacity yet. But yes, trained shooters and this like double incentive there to then go and check all the birds that have been shot to make sure that they're actually dead.
Okay, thank you. That sounds spot on, like it should be. And removal of eggs, is that, I'm not familiar with the species very well, but removal of eggs, does that help in any way? Is that an option?
I'm really not sure. It hasn't really been touched on too much in the work that I've done. Marilyn might be better at answering this question. I know that Paul McDonald that I mentioned before, him and Richard Major are doing a few more studies into noisy miner removal in the future because they've already been approved. And I think that they might be having a focus on nests specifically. So there might be some more information coming up there about that, but I'm really not sure about that. I haven't come across anything that talks about egg removal specifically.
When we did our culls, they were by trained shooters, and I collected all the birds that were culled personally, and any that were still breathing I euthanized with a CO2 bottle. I filled the plastic bag up with CO2, and they just went to sleep within seconds. As far as the eggs go, when we did our culls, once the noisy miners were culled, the shooters shot the nest out and the eggs all broke. And any nestlings that were there, I euthanized. It wasn't a very nice job.
Yes,
Oh, sorry, go ahead.
Sorry, I had a student once who looked at pigeons that are a problem in the buildings. And then a lot of people would go and, you know, where you clean the nest sites on a regular basis and you remove all the eggs. So I was just curious. But I think you guys are very fortunate because I think here in South Africa, the cost of a bullet for every bird would be excessive. They don't do that. For example, they consider a bullet for a seal cub to be too much. So it's nice to hear the welfare behind the decisions. It makes the decisions easier. Thank you.
Yeah, we used shotguns. So sometimes one shot would actually kill 2 or 3 miners.
Okay, thanks for the clarity. Thanks.
Good. Well, I don't have any more questions readily at hand. Anne, I don't know if you've got more.
No, just that it was really interesting, and I want to thank you guys, and a fascinating topic. Thank you.
Thanks, Anne.
Yeah, thank you very much, Courtney, for an interesting presentation, and for the time that you put in preparing for this. I know it's not a matter of just showing up and just running with it. So thanks for the time that you put in. And then, of course, this will be available on the SCB's Vimeo channel. So I will let you know as soon as that's up there. It should be within a day or so. And then it's free for dissemination and yeah, whoever wants to see. As I mentioned to you previously, I've shared these things with my colleagues who lecture nature conservation, because I think there's such a breadth of topics that's been addressed that I think in virtually all the modules there are videos that can be used for teaching purposes, linked to the paper, of course. So thank you very much. And yeah, with that,